jumping to the first part, that is about framing the educational context, and by that I mean what kind of knowledge that is needed to go in and use simulation for analyzing urban design as well as building design, and then an introduction to Autodesk related tools that can be used in this workflow. Before jumping into the more specific, I will introduce an example of what simulation and analysis is about. So is it possible to analyze one design? Maybe, but where the tools have the biggest strength in this early stage of design, that is when you have different designs. So the second question for this could be, is it possible to compare different types of design? In this case, some fruits. It would not be a good idea to study, let's say, the glazing percent of these designs, but it would be possible to study shapes if these shapes have the same square meter, so to say. So it's about when we compare stuff, it needs to have the same properties, so to say, and if you want to study, you only change one parameter. In this case, it is the shape we are looking at and not the glazing percent. If we had the same design, then we could look at a different glazing percentage, for example. So just to have that in mind, it's about comparing. That is where these tools are most effective, especially in the early stage. Alright, jumping to the first part where I will introduce Autodesk simulation tools. The tools that I'm used in the courses I've been teaching, the tools I'm also using in my own practice, and I've divided up in this family tree, so to say. So we have our main products as the Revit and Dynamo, and Format comes in, and maybe Roudsari will not be there. And we have all the small children's, that's the simulation functionalities and functionalities for visualization. And then we have some cousins, some third-party plugins, either directly for Revit or Dynamo. I will show some example of. So this section is about how I read these simulations and how I typically teach people to read this. Some is you can always discuss how to read some of these outputs, especially the ones that is dealing with on the urban level. I have a case project in this context, and so we can recognize what I'm going to show. This is just an extension to Technical University of Denmark. And the things I will show in this section, it will be based on some visualization set up on sheets to keep as much as possible within this environment and make it easier to come back and look at. So it's important to notice this, the visualization part and the documentation of these steps we're going through. Shadows. I'm not going to show that much about shadows, but this is one of the interesting tips, making this shadow range that kind of effective in the early stage to study sun and shadow pattern in a context. So again, all these examples I have here, I have 3 examples, so we easily visually can compare these ones. So that's one of the strengths. So this is done in Revit, so it's possible to make these kind of things if you know the right hacks. Wind comfort, we don't want to have this happen, so that's why we are going in early and study the wind pattern in our model. And in the same way, having side by side, we easily can see differences between different concepts. So one thing that could also be discussed, the way I read this output of the wind simulation is not the numbers. I'm reading it more visually, saying that if I go back, the blue parts, that's the area that is comfortable, and the red part is where I need to have more concern, or the critical parts in the wind simulation. So also these functionalities in Roudsari and flow design, it's maybe not the most accurate ones, therefore I'm not looking at numbers. For me it's more interesting to see the patterns, let's say. So where do I have the critical part, where do I have the good parts? Going further about how important it is about the color scale when we are looking at these kind of simulation visually. Either it's in the 2D, it's not that accurate, it should only be used for conceptual studies and not this contextual study. And the last two one is the same simulation where I just change the color scale, minimum and maximum value, where I'm in the last one getting more information in the visual part. That is what I'm interested in at this stage. So we can see that we don't have any red areas in this one, but we have it when we lower the minimum and maximum wind speed for the scale. So that's really important to have in mind. We also need to figure out where we have the winds. It's a really good idea to simulate more than one direction to give a more holistic understanding of the wind pattern. And you should also notice that I'm using the wind pattern and not wind speed or stuff like that. It's more like understanding the pattern of the wind. If you're working in different scales, you need to zoom in because especially with Roudsari, there's some limitation on how big. Then you need to do it in different steps. No problem with that. Just figure out where do you have the critical part and then making a smaller section of that. So I have these small icons. Down here it's referring to the different tools. So, but you could do this in Flow Design as well. That's the new product. This is from Flow Design. It could be an interesting study to understand where do we have the wind pressure on the building. That could be on a concept level, of course, the use of cross ventilation, for example, or related to ventilation strategies. Going further to the solar radiation, and that's about how much energy a surface is receiving from the sun, but it's also about, in indirect way, about how much light you're getting, the direct light. Again, we have it side by side here, just to show how it can be used. But it's also interesting to, not only in the outdoor space, but also on the building, and especially on the existing buildings that we have in the first one, because old buildings typically receive more or use more of the passive solar gain, at least in Denmark. That's a benefit of using passive solar gain. So when we put new buildings in, it will have an effect in both ways, so to say. So the context will affect the new building, but the new building will also affect the existing, and that is something that not everybody is aware of, that it have this double thing. The scale again is a little bit tricky to understand. It a little bit abstract, so to say. So you could say in the early stage it's about understanding where do we have the high levels and low levels, and later on you maybe want to put some numbers on or use this information for optimizing shade or similar. And this one, that's that one that could be discussed, but I'm also using the radiation studies to say, okay, in this area of the building on where we have a lot of radiation, there is also a link to the direct light. This is based on the weather data, so we can see there is a similarity. It's maybe obvious, but it is between the radiation and the illuminance, that is the light level. So you could say when you do a radiation, you also get some kind of feedback where in the building you will have problem with glare. And that leads to daylight. What kind of possibility we have with the tools here. Here we only have the option of doing daylight studies within a object-based model, and that means it's not only a Mars object. And this is a quite good way of studying the design with these three images. The shadows, that's visualizing the shadows in a raw way. The middle one is more like what is the feeling of the space, and the last one is the analytical view of the room. So this we can do for all time steps, and it will be really good to relate those to the one we can do with the light analysis that's simulate in relation to the LEED credit certification. In the same way, if you didn't know, we actually can make shadow studies as a section without, so to say, losing the geometry above. So this is the actually shade pattern inside the building. So it's similar to the perspective view, and it's interesting to look at both, so to say. And of course, when you are looking at design concepts or different options, then you should compare it in a similar way as I showed earlier on with a different proposal, but have not in this one. So again, we have to be very careful about the color scale when we are working with simulation, because it can mislead the information, as you maybe think in the left one there is no decent light levels in this space, but if you change for the color scale, then you actually will see that, oh, there is good daylight levels in this space. And this happens especially when you use the lead, because the lead are not focusing that much about looking more about when is the below this threshold of 300 lux and when it's above. So that's why it comes out in this way. But if I use another scale for the output, then I actually get the information I want to have. The energy simulation report, I think there's too much information. There is some basic information that I typically look at and some few numbers, that's it. And then do some after processing, and I will show some example later. And there's also something about the light result we're getting. It's based on the square meters and not affected by the size of the window. This one is also important. It's about controlling square meters. It's maybe boring, but square meters can actually tell us a lot. For example, the surface to volume ratio. It has a relation to heat loss, you could say. And of course it has a direct link to cost, so that is also interesting to look at this early stage. And for that we have schedules, and in this case I've used this for a student course to show them possibilities where I actually make my own communication of these results, having built a simple bar chart with the energy number and showing the square meters so I could compare it. I'll show some of the results later on here. Using sheets to set these kind of things up and keep stuff inside the Revit environment. Could also be more communicating, creating these informative scheduling or the filters. Now we are on the space planning level. Show when is the space too big in relation to my space program. So there is a lot of possibility to work with also square meters and get information, visual information. That is what I like to have, and also to communicate to others if I'm making consultancy. Then to some of the cousins plugins, the Tally. It gives feedback about global warming potential and embodied energy. When we're looking at simulation and stuff like that, especially in Denmark, I think we have reached a level where it's not so much about the operational energy, it's more about the embodied energy that is interesting, as well as the comfort. So then this kind of tools getting more and more important, or the embodied energy, to look at that one. So then we apply, as we know from Revit, we have thermal properties, but with Tally we can apply properties relating to the global warming potential and embodied energy. Really easy to use it. And the last I want to put in this section is a plugin that's called Sapphire. I really like the communication of the result, communicate the energy result in three icons, so to say: the energy use, the distribution of the energy divided up in heating, cooling, lighting, and glare and daylight as well. So it gives a quick feedback, and it's giving you real-time feedback actually. But unfortunately it only works on objects. That means that you have to have an object model. I think this tool is probably best if you only have mass objects. I really like the graphical interface with these three simple communicating icons. And it creates also this conceptual daylight result that is also getting more and more important when we are getting an envelope that is so well insulated. So it's not about energy, it's more about comfort, light and thermal comfort. So some few examples from some student projects. It's really learningful to teach and see how these students trying to communicate the results. But first I will show this brief example. It's not a design process, but the aim of this course was to try to teach students in 1.5 weeks to use Revit, going through this kind of workflow learning Revit modeling, learning these 4 different types of simulation, the LCA, the energy and daylight, and wind studies. It was more about learning and try to do some after processing of the result that I will show. They was taught to get an understanding of what kind of capability do we have in different model detail levels, the massing level and the object level, and what kind of result they could get from this. In this example, I've only taken maybe the little bit boring part about the graph, but it is actually here when these things are getting more interesting when we combine different stuff and compare. And this one is comparing the embodied energy and the energy use. And this was actually their result, and then I found out that there was a lot of problems in the model, so I had to change the models. But I learned a lot from that, and I probably think they also learned some things from that. And that's also some of the limitation with the energy simulation, if you're talking about glazing. The glazing you can choose in Revit is quite limited, so I had to make my own glazing properties. And that's a little bit tricky, but it's possible. Looking at compactness of these proposals, and it also quite interesting to compare the result with the compactness to see what kind of pattern do we have between those. And this kind of comparing overview of compactness, window to wall ratio, and so on, to get a more holistic understanding. Probably not that easy to read just from your point of view here, but it is at this stage things getting more interesting to compare different parameters, and through this understand the designs and how they perform. Another example where this case project is used. So this is mainly also about energy, and we see here also again some after processing that actually these kind of proposals they came up with, there is quite of difference. So it was just to prove that okay, it gives some kind of feedback, and it's not the same depending on the shapes. It will have different performance. But again, there is a need of setting things up in this way to have it overview of all the different performance of these proposals. And taking the step further, it's the same course they also had to put in the programs into these masses they have created, trying in a way to communicate how they have structured this part. And this gave actually even a bigger difference in the result of the energy use they got into space planning. And here last some example of from different courses that I just really like, and a good way of do this kind of communication of the result you're getting. It's not only about pushing the bottom and that's it. You also need to go in, if you should communicate it to other or to yourself at some point, write some small notes. Where do we have some problems and where do we have some good spots? And again, it's just with the radiation. As you can see, it's different layout the students have come up with. And these one as well, comparing before and after with some small notes. And these notes is really important that if you have to communicate it to others, if you are not a specialist, then you maybe don't know what it means when they have some kind of light level or whatever, or where is the critical parts and so on. So that's why it's so important to put this layering on top of the results. And finally, for this section, these environmental section can be super useful or to communicate the different strategies and summarize it in the section of a building in this way. This one is also interesting to document the process and the steps you have been through. So you have a documentation of what kind of decision have you made during your process. Probably is mainly most useful for internal use, but could also be to show the client we have considered these kind of strategies, and therefore we have taken a decision in this kind of direction. To check out more student projects, try to go to this site where we have collected a lot of student projects and student examples as a big database of good examples, so to say. So some example from practice that I've done in my own company or together with other consultants. Example of a typology study before going into design to get an understanding of which kind of building typology is useful, looking at different parameters
like heating and cooling loads, daylight levels, visibility, radiation, and to understand these patterns between these different parameters, and based on that have a better foundation on choosing a typology that could be detailed and used in the later design.
And if we look at wind studies, in all these examples I'm showing comparing with small nodes where I'm comparing to different proposals. That is especially with the wind where it's the most useful. And it's also interesting always to compare it to the existing conditions when we put stuff into this site. And the other one is useful when using this that is called the isosurface, creating some kind of three-dimensional surface with different wind speeds. It's a little bit tricky to understand in the beginning, but it's beneath this blue one or this green one, it has certain wind speed. So if you're working with a non-flat site, then this is useful, so it will be influenced by the curvature of the terrain. And some daylight and facade studies. And here's interesting that when setting this kind of studies up, it's really good to have it placed similar, so you easily can jump between different examples or proposals.
The last example I want to show you is an example done together with E3 Lab, where we were a team that analyzed some early conceptual studies and some later design proposals. So I'll briefly show some example from the report to give you a more holistic overview of how this kind of report could look like, especially when we are talking about consultancy. It is a project in Milan in Italy, and as we see here we have of course a front page. That's always a good idea, and a content and what kind of analysis we have done, starting the climate analysis, looking at that and extracting what can we get from that. In this example, we are looking at temperatures to understand is it a humid or cold climate or whatever. I don't want to go into detail in this. Here we actually also see that comparing different sites, China, Milan and Copenhagen, and have some few notes to these analysis to make it easier for the client to read these kind of tables. And this is just about the radiation and some few old architecture on how the building tradition is to get a deeper understanding of what is this kind of climate. And further going to the psychometric chart that is quite effective to understand how often the climate is in the comfort zone based on the climate data. And by applying some different strategies, it maybe get more hours into the comfort zone. And to some selected option that we have analyzed more deeply, that was selected by the client to show visually what is it for kind of concept that we have been looking at. First of all, looking at shading analysis, how is relation between shadows and sun-lit areas, radiation, analysis of the wind, to do some analysis for exterior wind conditions, as we see here. Again, we easily can read the different proposals because we are side by side, and here we also use this, as I mentioned, this color legend and a short note about what we can read from these images. Some early daylight studies that is really helpful to understand how is the daylight distribution in these types of proposals. So there's not that big difference in this one because it's almost the same depth, but the shape makes it different. And last, and energy and square meter comparing or analysis, as well as annual carbon emission. And these studies are done with Roudsari, and making a visual comparing between these different metrics or ways of looking at the design
with this visual smiley icon to make it more visual to the client. And again, a short note, jumping to facade studies, looking what kind of glazing percent is ideal or would be ideal for the different orientation: south, north, east, and west. And then we have some recommendation which facade layout they should choose based on the different studies here, the energy and the glare potential or the glare risk. And again, we're using here the smiley icon to make it more visual. And some conclusion based on all these different kind of studies: what is it we have done, what have we been looking at, and how much could these improvements have energy savings, and in the end related to the energy classes. To summarize what we have been or could learn from this part of the presentation about the educational context. In all these sections about learning from, I have put together some key points summarizing the section. First of all, knowing how to read these simulations. If you don't, they are not that useful. And it's also important to stress that simulation is not an analysis. It's just a raw simulation that gives you some kind of data feedback. And what is this kind of data it provides you with? So it's really important to take and read these simulations and trying to do some analysis, putting some notes on top of the simulation or comments or whatever, as we have seen in some of the examples, both from the students' projects but also from the consultancy projects I've been showing. And third, as I already mentioned, that is, these kind of simulation need some kind of after processing, like some nice setup layouts for visual communication, because in many cases these simulation or analysis is communicated to designers that actually don't know anything about these metrics or building physics phenomena that is occurring in most of the simulations. So that leading actually to the final key point, that also knowing the degree of feedback, how much can you read of the simulation? Does it help you in any way? And what kind of limitation is there, not only in the feedback or with the simulation, but also within the tool? Can the tool help you with the specific simulation you want to do or not? And that is some things that we will show more deeply in the next part of the presentation here.